Hello, and welcome to our first set of notes for Unit 5. Now, Unit 5, if I could summarize it, is about systems of equations and inequalities in matrices. And we'll see the relation between those two ideas here in the upcoming sections. But for now, I just want to take some time to review solving systems of linear equations algebraically. To be fully honest, this content is not going to be assessed, but making sure we have a good understanding of this content is really important so that we can move forward, making sure we understand some of the more basic ideas. So whenever we're solving a system of equations, we want to find the value of the variables that make each equation true. We want to find what values of x and y make each equation true. So the first thing we're going to talk is solving with substitution. We're going to do substitution and elimination today and just work through the steps. So when we solve with substitution, the first thing we want to do is identify the variable we want to isolate, the one we want to get all by itself. And then we'll use algebra to isolate that variable. So looking at our sample problem to the right here, negative 4x minus 8y equals 0, negative 3x plus y equals 7. I'm going to isolate this y. Now why would I do that? Because it doesn't have a coefficient. It's not going to take many steps. All I need to do is add 3x to both sides, add 3x here, and we find that y equals 3x plus 7. There we go. Now that we've solved this, we're going to plug in the value for that variable we solved for into the other equation for that same variable. So I solved the second equation, which means in my first equation, where this y is, I'm going to plug in 3x plus 7. Here we go. Just hit it a bunch of times and it'll go away. That's what they said. There you go. Cool. Alright, so y equals 3x plus 7. So I'm going to say negative 4x minus 8 times 3x plus 7 equals 0. Distribute here, so negative 4x minus 24x equals, no, so that'll be 56. It'll be positive 56. Let's not try to do too many steps at once here though. So minus 56 equals 0. So I'll get negative 28x equals 56. Divide by negative 28. Divide by negative 28, and we'll find that x equals negative 2. So notice when we did that, we only had one variable that we needed to solve for now, x. And we solved and we found that x equals negative 2. So now that I know x is negative 2, I'm going to plug in the value you found for the variable back into the original equation. I also like to just use this equation here again. Y equals 3x plus 7. So if y equals 3x plus 7, I can say y equals 3 times negative 2 plus 7. So y is negative 6 plus 7. Y equals 1. So we now solved for the other variable. And of course, since this is a system of equation, we need to write our answer as a coordinate pair because it's an actual coordinate where these lines cross, and that would be at the coordinate negative 2, comma 1. And that's the process. So if you would like to go ahead and do A, B, and C on your own to make sure you got it, go ahead and do that. Otherwise, we can do it together. If you want to do it on your own, pause it, and then you can check it as we go through it together. Otherwise, let's go ahead and start with letter A. Y equals negative 5x minus 12, and 6x minus 2y is negative 8. So notice this one already has y isolated, so I can just go ahead and plug that into this negative 2y down here. So I'll have 6x minus 2 times negative 5x minus 12 equals negative 8. So 6x, negative times a negative gives us a positive. Negative times a negative also gives us a positive. It's negative 8. So this is going to be 16x equals, when I subtract 24, I'll get negative 32. Divide by 16, divide by 16. and I find that x equals -2. Now that I know x is -2, I can plug that in to that top equation. Y equals -5 times -2 minus 12. Negative times a negative will give me a positive. Y equals 10 minus 12. So that means y equals -2. So my solution here would be the corner point, -2, comma, -2. There we go. Looking at letter B, I add 2y in this top equation to solve for this x here. That will tell me that x equals 2y minus 2. So I can say -6 times 2y minus 2 plus 4y equals -4. So -12y plus 12 plus 4y equals -4. Let's see, -12y plus 4y would be -8y. I would also subtract the 12, so this would give me -16 divided by -8. And I find that y equals 2. Once I know that y equals 2, I can plug it in up top here. X equals 2 times 2 minus 2. So x will equal 4 minus 2, which is 2. And that'll give me the coordinate point, 2, 2 for this one. Very nice. All right, now this one, nothing really too pleasurable to see here. -x plus 6y. I suppose this -x would be the easiest one to get. So I will say -x equals -6y minus 19, which means that x equals 6y plus 19. Once I switch all those signs. So I will have -3 times 6y plus 19 plus 18y equals -57. -3 times 6y is -18y. -3 times 19 is -57. Plus 18y equals -57. Now this is unique. Check this out. -18y plus 18y is just 0. So I'm left with -57 equals -57. My variable's gone. What does this mean? Well, this introduces us to one of our situations where we don't just have one solution. In this case, we would have infinite solutions because we got a true statement with no variables. So let's go ahead and check and make sure we understand the possible ideas. It's possible to have one solution, no solution, or infinite solution. And I'm going to represent this in a graphical perspective. One solution would mean the lines intersect at one point. Now, algebraically, what that means is you're going to get x equals a number and y equals a number. And of course, we'd write it as the coordinate pair x comma y. That's the one point where both of those lines intersect. No solutions means the lines do not intersect. Which means that they are indeed parallel lines. And how that will look algebraically when we'll solve it is we'll get an untrue statement with no variables. Untrue statement with no variables. It'll be something like 0 equals 7. Something like that, where we get two numbers that the equation says have to equal each other, but we know they don't. Now, infinite solutions would mean the equations represent the same line. So this is like our situation that we had with letter C up above. The equations, the two equations that we had here, -x plus 6y equals -19, -3x plus 18y is -57, those represent the same line, which is why when we solved it, we got a true statement with no variables. And a very common one you'll see in that case is 0 equals 0. You'll get something like that. So now that we have that in mind, we've talked about substitution, let's talk about elimination. So, when we're solving with elimination, the first thing we need to do is identify the variable that we want to eliminate. Now, looking at my example here, there's a couple different ways you can approach it. We can choose to eliminate x, or we can choose to eliminate y. Really, we just need to pick one. In this case, neither one would be too difficult. If we want to eliminate x, we would need to multiply the top equation by 3. If we want to eliminate y, we need to multiply the top equation by 5. 3 is smaller than 5, so let's just multiply this top equation by 3. And this is us to eliminate x. This is us using algebra to set up the equations for elimination. So when I multiply that top equation by 3, I'm now going to have negative 9x plus 6y equals 9. So what I'm going to do here is I'm going to go ahead and, since these are opposites, I'm going to add these together. So positive 9 plus negative 9 will give me 0x. If they were the same, I'd subtract, because 9 minus 9. Negative 10y plus 6y would give me negative 4y. And 5 plus 9 would give me 14. So I'm left with negative 4y equals 14. And now what we're going to do is we're going to solve this equation. Notice we only have one variable remaining. So all I have to do is divide by negative 4, divide by negative 4. And I find that y equals negative 7/2. Now that I know that, I'm going to plug in that value, y equals negative 7/2, into one of the original equations. So I'm going to plug that in for y. Let's do it in the top equation here. So negative 3x plus 2 times negative 7/2 equals 3. And now I can solve for the other variable, in this case, x. So I'm going to say negative 3x, these 2's would multiply out, minus 7 equals 3. Add 7 to both sides, 3 plus 7 is 10. So negative 3x is 10, divide by negative 3, divide by negative 3. And we find that x equals negative 10/3. Now notice my answer is fractions. That can happen. Don't be afraid if you get fractions for your answers. And of course we need to write our answer as a coordinate pair. So here I would write negative 10/3, comma, negative 7/2. Beautiful. And that's elimination. Alright, so let's try to use elimination to solve these equations here. A, B, and C. If you want to try them on your own, feel free to pause the video, and then as we go through it, you can use that to check your answer. Or if you want to do it together, feel free to stick with me and we'll knock them out right now. Looking at letter A, 2x minus 7y equals 16. Negative 4x plus 7y is negative 4. So I notice right away, negative 7y and positive 7y, those are already the same. One's negative, one's positive. In order to eliminate that, then I would just need to add these equations together. So I'm going to add the equations together. 2x plus negative 4x would give me negative 2x. Negative 7y plus 7y would just become 0. And 16 plus negative 4 would be 12. So I'm left with negative 2x equals 12. I can divide by negative 2, divide by negative 2, and I find that x equals negative 6. So now that I know x is negative 6, I can plug that into either equation. Let's do the top one here. So 2 times negative 6 minus 7y equals 16. 2 times negative 6 is negative 12 minus 7y equals 16. Add 12 to both sides, I get negative 7y equals 28. Divide by negative 7, divide by negative 7. And I find that y equals negative 4. So my solution then would be negative 6, comma, negative 4. There we go. Alright, looking at letter B, 5x plus 5y is negative 15, 2x plus 3y is negative 16. Oh, gross. So this is one where I'm going to have to multiply both equations, because 5, 2, and 3 do not have any multiples there inherently. I'm going to have to change these all up. So I'm going to multiply the top equation by 2. I'm going to multiply the bottom equation by 5 so that I can eliminate x. So when I do that, I'm going to have 10x plus 10y is negative 30. 10x plus 15y is negative 80. 5 times negative 16. Woof. All right. Now in this case, let's see here. Since I have the same variable here, I'm going to subtract the bottom equation. Again, it says 10 minus 10 is 0. 10 minus 15 is negative 5. Negative 30 minus negative 80. So that'll become negative 30 plus 80. That'll become 50. So I can divide by negative 5, divide by negative 5, and I find that y equals negative 10. So now that I know y is negative 10, plug it into either of these equations. I'm going to do the top one. 5x plus 5 times negative 10 equals negative 15. That means that 5x minus 50 is negative 15. Add 50, so I get 5x equals 35. Divide by 5, divide by 5, and I find that x equals 7. So my solution for this one would be 7, comma, negative 10. Very nice. All right, last one. Letter C. Oh boy. Let's multiply this top equation by 3 so that we can eliminate the y's. So I'm going to have negative 21x plus 9y equals 3 times 22 is 66. Alright, since I'm going to be subtracting, because 9 minus 9 is 0, so 3x plus 21 will become 24x. 9y minus 9y will become 0. Negative 30 minus 66 will become negative 96. Gross. So 24x equals negative 96. That's a big number, but fortunately it is divisible by 24. Negative 96 divided by 24 tells me that x equals negative 4. So now that I know x is negative 4, I can just plug that in. So I'll do the bottom equation this time because I'm feeling creative. 3 times negative 4 plus 9y equals negative 30. So this will become negative 12. Plus 9y is negative 30. I'm going to have to add 12 to both sides. Negative 30 plus 12 would become negative 18. And when I divide by 9, I'm going to find that y equals negative 2. So my solution for this one, negative 4, comma, negative 2. There we go. All right, hopefully we're feeling good about substitution and elimination. The last thing I want us to try is equations that aren't already in standard form or slope-intercept form, equations that might be in a little different form. We can still use substitution, elimination, whichever one really works out. So that's what we're going to talk about here. First of all, looking at letter A, I see that the zeros I could set these equations equal to each other as they are since they both equal 0, but then I'd have two variables in one equation. That doesn't really help much. So rather than doing that, let's see, what could we do first? We could just rewrite this in standard form. That'd be one thing we could do. So to do that, I can move my variables to the left side here. So I'd have to add 9x, I'd have to subtract 12y, and that would equal negative 3. I would have to add 6x, I would have to add 4y, and that would equal 10. And then it's just like a problem from above. I can multiply this bottom equation by 3. So that'll give me, the top equation wouldn't change. 9x minus 12y is negative 3. The bottom equation would become 18x plus 12y equals 30. And I would be subtracting these ideas here. Oh wait, no, I'd be adding, wouldn't I, since this is a negative and a positive. So 9x plus 18x would become 27x plus 0 equals negative 3 plus 30 would become 27. So that works out well. X equals 1. Now that I know x is 1, I can plug that into one of my equations from up top. We can do this 6x plus 4y equals 10. So that would be 6 plus 4y equals 10. Subtract 6, so 4y would equal 4. Which means also y equals 1. So my solution here would be 1, comma 1. Now if you're ever in doubt, you can always plug these in to the values to see what we get. So if I plug this into the top equation here, it'd be 12 minus 9 minus 3. Does that equal 0? Yeah, it does. 12 minus 9 is 3. 3 minus 3 is 0. If I plug it into the bottom one here, this would be negative 6 minus 4 plus 10. Does that equal 0? Well, negative 6 minus 4 is negative 10. Negative 10 plus 10 is indeed 0. So that's how I can be confident in my answer. All right. Oh, it's reappeared. Hit it just a bunch of times and it'll go away. Weird. Okay. So looking at letter B, 1 equals 3x minus y. Negative 4 plus 12x equals 4y. Oh, how do we want to do this here? Well, we can solve for y here pretty easily just by dividing by 4, and all of that divides by 4 pretty well. So I would get negative 1 plus 3x equals y, and then I can substitute that into the top equation up top here. So I'd have 1 equals 3x minus negative 1 plus 3x. So that would get me 1 equals 3x plus 1 minus 3x. Now notice here, 3x minus 3x would be 0, so I'm left with just 1 equals 1. Oh, hey, this is a true statement with no variables. What does that mean? That means infinite solutions. Excellent. Fantastic. Well done, team. All right, letter C, 2 equals 4x plus 5y. 0 equals negative 2y minus 7x minus 10. Okay, so looking at this here, I'm thinking it'd be difficult to isolate a variable here. Let's get this in standard form and see if we can't use elimination. To do that, I could add 10 to both sides. So I'd get 4x plus 5y equals 2. Negative 7x minus 2y equals 10. So I can multiply this top equation by 2, I can multiply the bottom one by 5 and eliminate my y's here. When I do that, I would get 8x plus 10y equals 4. Negative 35x minus 10y equals 50. Woof. Alright, and we are going to, it looks like, add these together since I have a positive and a negative. When I do that, 8x minus or plus negative 35x would give me negative 27x. 10y plus minus 10y would give me 0. 4 plus 50 is 54. Oh, this actually works out well. Divided by negative 27. 54 divided by negative 27 tells me that x equals negative 2. Now that I know x is negative 2, plug it into this top equation up here. So 2 equals 4 times negative 2. Plus 5y. 4 times negative 2 is negative 8. Add the 8, so I'm going to get 10 is 5y. Divide by 5, divide by 5. And we find that y equals 2. Now, of course, that's not my final answer. My final answer would be that coordinate pair, negative 2, comma 2. And that's what we'll box right there. Beautiful. All right. Well, if you have any questions, please don't hesitate to let me know. Feel free to send me an email. Like I said, this information is not going to be on the Unit 5 test. This is just important information to you to know, for you to know moving forward. We're going to refer to systems of equations, especially with one solution, no solution, and infinite solution. We're going to build on that idea a lot as we get into equations with more than 2 variables, as we get into 3 variable equations. So make sure you're feeling confident on these ideas. If you want more practice, feel free to do the practice problems. Otherwise, just make sure we understand this idea, and we'll look forward to 5.2 here in a couple of days. Mr. Carter signing off. I'll see you next time.